Hello everybody, welcome back to another video. In this video again we're going to be talking about how to solve differential equations by separation of variables, but in this case we're going to be specifically focusing on the medium type of differential equations. Alright, let's get started. In the first problem we have dy over dx is equal to 4 times x times y. So again, we're going to do cross multiplication, but there's invisible 1 right here. So when I do the cross multiplication, what I'm going to get is right here, dy equals 4xy equals 4xy times dx. Alright, so on the right hand side we have 4x and dx. Okay, but we have to get rid of this. We have to dispose of this y, variable y. So the only way is to divide each side by y. So when I do that, we get dy over y is equal to 4x times dx. So now, since the variables are separated on both sides, so we're going to integrate. So we know that the integral of dy over y is equal to just natural log y equals the integral of 4x by applying the power rule. So we get it's going to be equal to 4x squared divided by 2 plus c. If I simplify this one a little bit, we get natural log y is equal to 2x squared plus c. Alright, so as you can see that the variable y is not by itself, so we have to isolate it. The only way we can isolate it, we're going to exponentiate both sides. So we get these e and ln will get cancelled, so we get y is equal to e to the power of 2x squared plus c. So I can rewrite this expression like this, e to the power of 2x squared times e to the power of c, because we know that for the exponential numbers, addition implies multiplication. So we get c, capital letter C, times e to the power of 2x squared as my solution. If I set this e to the power of c is equal to c, because they're still constant numbers and it doesn't matter what constant number we have. So that's the answer of the first problem. Alright, so let's move on to the second problem. Before that, let me erase the board. In the second problem, what we have is this differential equation. So again, we're going to always start off doing the cross multiplication. So we get x squared plus 3 times dy is equal to 2xy times dx. Alright, so first we have to move this y across over here, and we have to move this x squared plus 3 across over here. So first I'm going to divide each side by y. So we get x squared plus 3 times dy divided by y equals, we got 2x times dx. Okay, then we need to move this x squared plus 3 over to another side. We can do it only for division, by division. So that's going to be equal to dy over y equals 2x times dx divided by x squared plus 3. Alright, so we finally and successfully managed to separate the variables. So now we're going to integrate both sides. But for the right hand side, the integral, I need to apply the u substitution. So basically, if I set x squared plus 3 equal to u, what I'm going to get is 2x dx is equal to du. So we have this right on numerator. So basically, this integral dy over y equals 2x times dx divided by x squared plus 3 will be equal to natural log of y equals integral du over u. Okay, so natural log y is equal to, this is going to be natural log u plus c. So if I switch u back with its x squared plus 3, what we're going to get is natural log y is equal to natural log of x squared plus 3 and plus c. Alright, so we have to get rid of this natural logs so that we can get the variable y isolated. So I'm going to exponentiate both sides. So when I exponentiate both sides, what I'm going to get is y is equal to, So let me use a different color. So y is equal to e to the power of, actually, so let me erase a bit. Okay. So the y is going to be equal to y equals x squared plus 3 and times e to the power of c. Okay, so specifically, if I set this e to the power of c equal to capital letter C, the result is going to be equal to y equals c times x squared plus 3. That's the answer for number 2. Okay, so we're always doing the same thing because we know that our ultimate goal is to solve this equation for y. But first step is doing the cross multiplication. Okay, after we do the cross multiplication, we need to successfully separate the variables. Okay, and then we're going to integrate both sides using the methods that we have known so far. All right. Let's move on to the third problem. In this third problem, if I do the cross multiplication, what I'm going to get is y times dy times equals negative x times dx. Alright, you see that the variables are separated. Alright, so there's no problem. So it's safe to continue. So let's continue. Y squared divided by 2 equals negative x squared divided by 2 plus c. Alright, so we have to get rid of these 2. So in order to get rid of these 2, I'm going to multiply each side by 2. Okay, so when I do that, I'm going to get y squared negative x squared plus 2c. Alright, then we have to take the square root of each side to get the y by itself. So we get y equals negative x squared plus capital letter C under the square root as my general solution for number 3. For number 4, again, there's invisible 1 right here, so let's do the cross multiplication. So we get dy equals 8x cubed times y times dx. So we have to move this y over here so we can get the variables separated. So we get dy over y equals 8x cubed times dx. Alright, so the left hand side integral is going to be equal to natural log y equals 8 times x to the 4th over 4 plus c. And that's going to be equal to natural log y is equal to 2x to the 4th plus c. Alright, so we need to get rid of this natural log. The only way is to do it is, exponentiate both sides. So when I exponentiate both sides, what I'm going to get is y equals e to the power of 2x to the 4th times e to the power of lowercase c. So my final general solution will be y equals c times capital letter C times e to the power of 2x to the 4th. This is my general solution for number 4. Alright guys, in this video again we've talked about how to solve differential equations by separation of variables, but this time difficulty of the questions were medium. Alright, thanks so much. If you like this video, please subscribe for the many more upcoming math videos, like and share. Thanks. Bye bye.